Good morning, friends. Now we are discussing traveling salesman problem of module number 3 in the subject operation research. What is traveling salesman problem is? So here in this example, so the traveling salesman is assigned 5 cities. He need to cover all the 5 cities at least once. He can choose his sequence of visiting the places. So here the cost matrix is given here is transportation cost. So if he start from city A to city A, so there is no cost involved here. Similarly from city B to city B, so there is no transportation cost involved. So diagonally we have no cost involved. So, uh, if the traveling person A goes from A to B, the transportation cost incurred is 4 units of currency. From A to C, it is 10 units. From A to D, 14 units, so on. So he starts from a particular city, visit each city at least once, and then he has to return to the starting point from where he began his journey. So the cost matrix of going from one city to another city is shown below. Find the least cost route. That is, how do he plan visiting cities so that he has to visit all the cities at once. And one more condition is that from where he has started the journey, he has to return back to the same city. So as we do in other job assignment problem, we have to see whether the matrix given is profit matrix. It has to be converted into loss matrix. That is, we have to identify the highest profit and subtract from the other elements. So profit matrix will be converted into loss matrix. But now here, so the given matrix is cost matrix, so we need not convert it to loss matrix form. This is already in the loss matrix form only. So the first step here is to go for row minimization table. So that is individual row, we have to find out the lowest cost and subtract from the other elements. So the procedure is same as the assignment problem. Subtract the lowest cost from other elements row wise and column wise. So in the first iteration, row minimization. So the lower most cost is 2. Subtract 2 from the other elements like 4 minus 2, 2. 10 minus 2, 8. Then 14 minus 2, 12. 2 minus 2, 0. So individually in each row we are taking the lowermost element, subtract from the other elements. Second row, 4 is the lowest cost, subtract from the other elements. Third row, 8 is the lowest cost, subtract from the other elements. Fourth row, once again 8 is the lowest cost, subtract from the other elements. Here fifth row, so 2 is the lowermost cost, subtract from the other elements. Now we are getting row minimization table. From this table obtained, go for column minimization. So here column number 1, column number 2, column number 4 and 5 remains the same because they have 0 as the lowermost element. The third row is having 2 as the lowermost element. So subtract 2 from the other elements. So 8 minus 2, 6. 2 minus 2, 0 here. Then 4 minus 2, 2 here. 2 minus 2, 0. So we are getting column minimization table. Then draw minimum number of lines, maybe horizontal or vertical, to cover all the zeros. So number of lines drawn will be here 5. So we are having 4 vertical lines and 1 horizontal line. So minimum lines required will be 5. So it need not be only horizontal or only vertical. It may be combination of horizontal and vertical as well. Size of the matrix. It is 5 rows, 5 columns. So capital N is 5. Number of lines drawn is also 5. So now start allocating to the zeros. So the allocation will be started such a way that first we have to search any row or column where that row or column is having only one zero. First we will allocate to such zeros where there is only one zero present in a row or column. If we find then other zeros more than one in that particular row or column, when that particular zero is allocated, cross out the other zeros. So like this we are getting now allocation from A to E, then here E to A. So without visiting the other cities like B, C and D, so from A has started, go to E, from E he has returning to A. So without visiting all the cities once, so he cannot return to its origin. So this allocation does not holds good. So obtain the next best solution by assigning the next minimum non-zero element. So after 0, so the next non-zero element minimum is 2. So this 2 is allocated. So and crossing out the other zeros. So here 2 is allocated. So if we find other zeros and 2's in the particular row or column, we cross out them. So now the new allocation is A to B, then B to C, then C to D, then D to E, and then E to A from this table. So A to B, B to C, C to D, D to E, E to A. So the least cost route is now starting from A, returning to A. In between he go in the same sequence B, C, D, E. So total cost will be found out. A to B. So what is the cost given? So it is 4 rupees. So 4. Like this all the costs will be taken and it comes out to rupees 30. So this is the minimum transportation cost incurred to the traveling salesman. Thank you, friends.